Welcome back to Industrial Automation course, Lecture 12, Structured Text, ST Programming in Codesys. Today's topics are as follows: structured text, expressions, and evaluation of expressions. Structured text, instructions. Structured text, assignment operator. Calling functions, return, if, case instructions, for loop, while loop, repeat instructions, jump instruction and comments, examples, simple assignment, self-holding, timers, counters, and etc. Video tutorials. Selected video tutorials from YouTube. I strongly recommend students to look at these videos, watch them carefully, and follow the instruction on these videos as well. Structured text programming. If you know how to program in any high-level language, such as BASIC or C, you will be comfortable with the structured text programming. ST programming is part of the IEC 61131 standard. The structured text is a textual high-level programming language similar to Pascal or C. The program code is composed of expressions and instructions. Numerous constructions can be used for programming loops, thus allowing the development of complex algorithms. So here in this example, you will see one example of ST programming. It's very similar to C, BASIC, Pascal, or other high-level computer programmings. Structured text expressions. An expression is a construction which, after its evaluation, returns a value. This value is used in instructions. Expressions are composed of operators, operands, and/or assignments. An operand can be a constant, a variable, a function call, or another expression. So here we have few examples. For example, 33 is a constant, ivar is a variable, fct is a function call, a and b is an expression. This x multiplied by y divided by z is an expression, and real var2 equal to integer var is an assignment. Okay, so we have expressions, assignments, variables, constant, and function call, and we have operators and operands. Structured text, evaluation of expressions. The evaluation of expression takes place by means of processing the operators according to certain binding rules. Okay, so see what are these binding rules. The operator with the strongest binding is processed first. Then the operator with the next strongest binding, etc., until all operators have been processed. So here we have a list of operations and their symbols, and they are listed from the strongest to the weakest in terms of binding. So for example, put in the parentheses, okay, so expression in the parentheses. has a highest basically binding. Function call, exponentiation, negate, multiply, divide, module, add, subtract, compare, equal to, not equal to, boolean and, x or. Okay, so it's very similar to other computer programming like C. Okay, so almost the same, nothing new if you are familiar with the basic of those computer programming languages. A structured text instructions. Instructions tell what to do with the given expression. The following instructions can be used in ST. Okay, so we have expression and instructions will tell us what we need to do with those expressions. For example, here, see, look at this instruction. We have assignment. For example, A should be equal to B. Okay, and E and B are kind of expressions. Yes. So, or C plus 1 is expression, but here assignment is instruction. What we want to do with CV plus 1? Calling a function and use of the FP output. Okay, so here we are calling this function. This is an instruction, and then we have an assignment. Same for the return, if, expressions and instructions, and case. We'll explain these ones in coming slides. We have for loop, while loop, repeat, exit, continue, jump, and empty instruction. Again, we will explain them in coming slides. The structured text assignment operator. On the left side of an assignment, there is an operand, variable address, to which the value of the expression on the right side is assigned by the assignment operator. So here we have one operand, variable 1, and here we have one expression, and the assignment or equal sign is our instruction. After completion of this line, var1 has the tenfold value of var2 in this example. Set operator, s equal, the value will be set, that is, if one set to true will remain true. So A, S equal B. Okay, so what is this one? A gets the value of B. A here gets the value of B. If one set to true, it will remain true even if B gets false again. So B here is basically our signal or logic. When B is true, okay, so B is our contact, we could say, and A is coil. When B is true, A will be set to true, and it will remain and will stay true even though B goes false. Okay. Reset operator, the value will be reset, that is, if one set to false, it will remain false. A R equal to B. A is set to false as soon as B is true. Okay, so again, to avoid confusion, B is our contact and A is coil. Once B is true, A will be reset to 0 or false. Okay, so always set the value of a to true, and reset always set the value of a to false, and to basically action to happen. So action only happen once b is true for both of these cases. Watch this video for further instruction and examples. A structured text calling function blocks. A function block is called in a structured text according to the following syntax. So what is the syntax? Name of FP instance. Okay, so this is the name. FP input variable, value or address, further FP input variables until it finishes. Okay, so basically we need to feed all the inputs. Here we have one example. In the following example, a timer function block. So timers are a kind of function blocks. Okay, so these are default function blocks. It's called with assignments for the parameters in and pt. So this one is preset time value and this one is in. Then result variable q is assigned to variable a. The timer FB is initiated by TMR-TON. So TMR is one instance of TON or on-delay timer. The result variable, as in IL, is addressed according to syntax FB instance name dot FB variable. So here we have our function block. We are calling our function block, and inputs are in ix5, okay, it's a Boolean variable, and preset time value is 300. And we want to assign a with the value of TMRQ, which is the output value variable of timer. So once the timer is done, the Q will be true and A also will be true. Once A becomes false, the output of the timer Q also goes false and A becomes false. Please watch this video for further examples and instructions. The return instruction can be used to leave a POU, for example, depending on condition. Return. So this is a syntax return, and we want to see how we could use that. In this example, if B is equal to true, then return, okay? So it means that the rest of the program will be executed. If B is not true, then basically this line will be executed and the value of a plus 1 will be assigned to a. If B is true, instruction A equal to a plus 1 will not be executed. The POU will be left immediately. So it's very good for function blocks to basically have a return, to return the final value of the function block and terminate the function block. Watch this video for further instructions and examples. A structured text if instruction. With the if instruction, you can check a condition and depending upon this condition, execute instructions. So very similar to, let's say, C programming. If Boolean expression 1 true, then execute if instructions. Else if Okay, so once this one is not true, then it will check the next one, Boolean expression 2. If it's true, then we'll go to the expression and execute this one. So it will continue until it reaches to the end if. Okay, so once the first one is true, it will skip the others. The part in braces or these curly brackets is optional. So watch this video for again further instructions. Here we have one example. If temp is less than 17, then hitting on will be true, else hitting on will be false. Okay, so this is the temperature, for example. If it's less than 1, the heating system will be on, otherwise it will remain off. With the case instructions, one can combine several condition instructions with the same condition variable in one construct. So here we have syntax, case variable 1 of. So here we have a variable, and here it will check, for example, if the variable 1 is equal to value 1 or value 2 or value 3 or value 6 and so on and so forth until it reaches to the end. If it's equal to the value 1, the first instruction here will be executed, otherwise it will check the next until it reaches to the end case. Here we have one example, case integer 1 of. Equal, so if integer 1 is equal to 1 or 5, then boolean 1 will be true or becomes true, and the boolean 3 becomes false. If it's equal to 2, then this one, if it's 10 to 20, then this one will be executed, otherwise else none of these, then boolean 1 will be equal to not boolean 1, and boolean 2 will be equal to boolean 1 or boolean 2. Okay, so, and this is the end. So watch this video for further instruction and example. For loop instruction. With the for loop, one can program repeated process. Syntax here, integer variable int. Okay, so we define the integer variable first. Here we have our for loop, for integer variable equal to initial value to end value by step size, do instructions, then end for. Okay, so we could avoid having this step size here. So anything in braces in these curly brackets could be avoided. These are optionals. Yes. So here, for example, for counter 1 to 5. Okay, so how many times we go through this loop? 5 times by 1. Variable 1 is equal to variable 1 multiplied by 2. And end for, and finally outside the loop, variable 1 will be assigned to the variable erg. Please watch this video for further instructions and examples. The while loop can be used like the for loop, with the difference that the break-off condition can be any Boolean expression. This means you indicate a condition which, when it's fulfilled, the loop will be executed. Okay, so here is syntax, while Boolean expression, do instructions. Okay, so here, while counter is not equal to 0, then this one will be executed, okay? So until basically the counter reaches to 0, then it will get out of the while loop. The instructions are repeatedly executed as long as the Boolean expression returns true. If the Boolean expression is already false at the first evaluation, then the instructions are never executed. If Boolean expression never assumes the value false, then the instructions are repeated endlessly, which causes a repetitive time delay. Okay, so please watch this video for examples. The repeat loop is different from the while loop because the break-off condition is checked only after the loop has been executed. This means that the loop will run through at least once regardless of the wording of the break-off condition. Syntax: repeat instruction until Boolean expression and repeat. Okay, so we have slightly different syntax. First, you see that the condition is at the end, so we'll go through the loop once, at least once. Plus, the difference here is that in the while, difference between this repeat and the while, okay? In while, the condition should be true to go through the loop. But until here is different, yes? If the condition is false, then we'll repeat the loop. So the instructions are carried out until the Boolean expression returns true. Okay, so once this one is false, we'll repeat, okay? Once it becomes true, we'll get out of the loop. If Boolean expression is produced already at the first true evaluation, then instructions are executed only once. If Boolean expression never assumes the value of true, then the instructions are repeated endlessly, which causes a repetitive and relative time delay. Watch this video for further examples in Codesys. A structured text jump instruction. The jump instruction can be used for an unconditional jump, the code line marked by a jump label. Syntax: label, jump to label. Here we have one example. AAA is assigned to 0, and for this line we have label 11. We have some instructions here between, and finally we have this instruction here. If AAA is less than 10, then jump to label 1. So this is unconditional. It means that it doesn't check any condition. Once it reaches to this line, it will jump immediately to this line, okay? So the label is an arbitrary but unambiguous identifier that is placed at the beginning of a program line. The instruction jump has to be followed by the indication of the jump destination that has to equal a predefined label. When arriving the jump instruction, a fly back to the program line that is provided with the indicated label will be effective. So please watch this video for Codesys example. A structured text comments. There are two possibilities to write comments in a structured text object. Start the comment with parentheses open, star sign, and close it with the star sign and parentheses close. This allows comments which run over several lines. Example, this is a comment. Single line comments as an extension to the IEC 61131-3 standard is double slash, denotes that the start of a comment that ends with the end of the line. Example, double slash, this is a comment. This comment can be placed everywhere within the declaration or implementation part of the SD editor. Please watch this video for Codesys example. Here you see the example that this line is completely commented and won't be executed. Simple assignment program in ST. Create a new project and select ST as the programming language. Okay, so here we used to select ladder logic or LD. Here we want to use ST. In the project environment, there is no LLD or FBD components anymore. So we used to have contacts, cores, negate, etc. here, but we don't have them anymore. Everything should be developed by writing the code. Okay, so we just have access to coding and writing code, nothing else. The aim of the program is to change the value of the output coil motor according to the input contact start. This can simply be done by motor equals start. When you press the return key, automatic variable declaration window will pop up asking you for information regarding the new variables. Here, select Boolean as the variable type. Okay, so here, once we do so, we'll start this auto declaration window will pop up, and we need to define them. We want you to have a motor and start both as Boolean variables like or contacts and coils. Okay, so here you see the declare value. So declare the start variables as well. Save the project. Select simulation mode in the online menu. Log in and run the program. Check the functionality by forcing the value of the start variable. So another basically way is to declare these variables first before starting to write and use them in the program. Here we could force the variables. See, for example, we could force the value of the start and see what would be the effect on the motor variable. Self-holding programming in ST. Remember that in order to have the motor working in the self-holding mode, the start contact should be placed in parallel with the motor contact. Okay, so here basically kind of latching or self-holding. In ST, you only need to use OR instruction to perform the same task. Okay, so to implement the same program in ST, here we say motor is equal to start or motor. Okay, so parallel branches means or. Okay, so motor is equal to start or motor. Okay, so once the start goes false, since the motor already became true, so this here this expression is true and the motor will be true and stay true. Save the project, log in and check the functionality. Here the video for the implementation in Codesys. Watch the video. To stop the motor in the self-holding mode, and stop contact should be used in series with the start and motor contact. Here we have a stop, so a little bit more advanced code. In ST, you need to use AND. Okay, so we have two series contact, so it's similar to and parallel branches are OR, and group the previous OR part to perform the task. Okay, so here we have the ST coding. So motor is equal to not a stop, because this is a basically a default values clause. Okay, so not the stop, and now we have this part, start or motor. Okay, so save the project, log in, and check the functionality, see the implementation in Codesys. Calculating average of 5 numbers in ST. In this program, the aim is to calculate the average value of 5 numbers stored in an array F. Pay attention to the way in which the array is declared. Okay, so here the way we could declare it. Save the project, log in, force values for the array elements, and run the program. So for the elements of the array, first they are declared as integers, and we could force these variables and see what is the basically result. Here we have this decoding. The average variable at the beginning is 0 for I 0 to 4, because we only have 5 elements for this array. Average is equal to average plus fi, so we are summing up all values in this array, and when we get out of the end loop, then we'll divide it by 5. Okay, so this is just one way to implement this program. So again, easily you could implement it in Codesys. I recommend you to do so in Codesys. In this program, the aim is to generate a time delay 4 seconds between pressing the start push button and turning on the motor. This can be done using a TON. In ST, since TON is a function with input arguments, it should be declared and called in a correct way. So see how we declared a timer, TMR. So TMR is one instance of a TON. Pay attention to the way in which the timer is declared and its output is called. Save the project, log in, run the program, and check the functionality. Here you see the ST programming. So TMR input is going to be a start. So once the start is true, the timer will start timing, and preset time value is 4 seconds. Once it's done, once the timer is done, TMR.Q will be true, and the motor will be true or will be on. Okay, I strongly recommend you to write the code in Codesys and check the functionality of the program. Counters can be used in the same way as the timers in ST. You need to declare them and then calling them by providing the input arguments in a correct way. As you start to type the name of the declared counters in the program, you will see some hints on the inputs and output variables of the counter. Pay attention to the way in which the timer is declared and its input arguments are called, or counters. Okay, so you see that we declare one instance of CTU, which is CTU01, and once we start programming, you see that this menu will open, and we could get hint of the inputs of the time of the counter. So CU, the trigger is push button 1, reset is push button 2, and the preset value is 5. And basically the motor value will be timer.q. So what happens here is, okay, so Okay, so basically, if we press push button 1 5 times, the value of the counter will become true, okay? And if we use the value of this counter as input, then basically the motor will start 45 seconds after the counter is done. So in this program, the aim is to wait for the push button to be pushed 5 times. Afterwards, the TON will start, and after 4 seconds, the motor will start operating. By pressing push button 02, the counter will reset. Pay attention to the way in which the timer and counter are declared, and their output arguments are called. Okay, so as I explained in the previous slide, here the input of the timer now is output of the counter, and once the counter is done, then after 4 seconds, the motor will turn on. Okay, so I strongly recommend to follow this instruction, write the program, and check it by yourself in Codesys. Example of changing the preset value of the counter. In this program, the preset value of the counter will be changed based on input. So here we have variables. Here we have a, a ladder logic implementation of the code. So here we have a counter, and once, for example, the contact A is true, then the preset time value of 300 will be set for the counter, or if once this one is true, 175 will be the preset time value of the counter, and same for the last one. Once the C is true, then the preset time value of the counter will be 50. So we have this flexibility of selecting these default preset time values. We could implement this code in ST. Here we define the counter, so we are calling the counter as well, CTU01, CU, so the trigger is LS1, reset is reset, and the preset value for the counter is CTU-PV variable. Now we need to set the value of this CTU-PV. If A, so we are using if instruction here, if A then, so once A is true, then the preset value will be 10, otherwise B true, B, else if C 5, else preset value will be 0, and basically at the end of the program we want to set the value of full with this, the done bit of the counter. Okay, so once the counter is done, full will be true. Again, I strongly recommend you to write the program in Codesys and check the functionality by yourself and in the simulation. Using up-down counter, CTUD in ST, very similar to counter. Here you see the ladder logic programming example, up counter, down counter. Here we have CTUD block, function block, so you could easily declare one instance of this function block and then use it in your program. Implement the traffic lights control system shown in ST. So this is the exercise. I'm gonna leave this one to you. Please do it by yourself. Check it in Codesys, implement it in Codesys, and check it by the simulation, the performance of the program. Resources for ST programming Here we have further resources. If you want to get more guidance and details, please refer to these videos.